Good morning everybody. In the previous videos we had discussed about the couplings, different couplings and the keys and the joints. So now we'll just discuss about the design of muff coupling with all the calculations. So here, as you can see, this is a muff coupling or a sleeve coupling. So the parts of this are, as I discussed, the muff. This is the outer sleeve or the muff. This is the key and this is the shaft. So let us see the design of this coupling in this video. Muff, the shafts and the keys. The key. So we have the three parts of the coupling. So now to make you understand this concept of design, I'll just take the example of a clay doll. Imagine I ask you to create a clay doll or design a clay doll or make a clay doll. So basically what will you do? You will first create the body, then you will create the head, and then you will create the legs. So here you will create, after you create the body, you need to make the head. So you will not make the head as big or very small. You will not have a head which is so big. You will not have a head which is so small. What you will do is you will design an appropriate head. You will create appropriate legs and then the hands. So basically when you create a doll, first you make the body, then the head and then the legs. So the same way you will have some appropriate values, appropriate specific dimensions to make the doll. So in the same way, if I have a coupling, the coupling is basically a muff. So this muff is based on the shaft. So first you have to design the shaft. So you understand here, we have to design the shaft first, and based on this shaft we will design or create this outer muff. If I have a large shaft, I need to have a large muff. If I have a small shaft, I need to create it appropriately small in size, and then according to the shaft I'll create the muff, and with respect to both these I'll be creating the key. So here the procedure for this is design the shaft first and then the muff and then the key. So here, as you can see, the procedure for designing the clay. First, clay doll. First you will make the design of the body, then the design of the head, then design of the legs. Similarly in this muff coupling, you will design the shaft first, then the muff or sleeve, and then you will design the key. So the same way, let us see the procedure for that. Let us see the procedure method for muff coupling. It is very easy. I'll just show the details, the procedure first, and then we'll solve the problem. So here first we design the shaft, then the sleeve or the muff, and then the key. So let us see the muff coupling now. Design of muff coupling or sleeve coupling. So this is a muff coupling. I have drawn the diagram here. This is the outer sleeve which you just saw. This is the outer sleeve which you just can see here, the outer sleeve. This is the shaft, and this long thing is the key. I have written here the sleeve or muff, the key and the shaft. So as you all know, first we created the body, then the head and then the legs. So here also the same thing. First the shaft, according to the shaft we create the muff or the sleeve, and then according to both of them we design the key. So the same way, let us see the procedure. General rule: body, head and the legs. Same thing for general rule. The convention, it is just a convention. So according to this it is just a convention. So first we will design a shaft, then the sleeve and then the key. So the procedure here, as you can see, first one, when I go for design for shaft, I will have to find the torque first. They will have in the question they'll give you the power. Using the power you have to find the torque, and using the torque equation you have to find the diameter. As to how we'll do this, you can see in the further solving of the problems. It is very easy. Just you need to remember these 3 points. So after finding the diameter of the shaft, that is the diameter of this shaft, once you find the diameter of the shaft, using that diameter you will be finding. Second point is design of sleeve or muff. That is the second part. That is this design for sleeve or muff. So when you want to design that, you will use this diameter and find this outer diameter of the sleeve based on that, and then you will find the length of the sleeve, and then you need to check the shear stress. What is the shear stress? Checking for shear stress, I'll just show you while solving problem. Then we go for design for the key. What is this design for the key? Based on the shaft values, we will design the key. So this key will have certain width, it will have certain thickness and a certain length. So we need to find these three values, and after that we'll just check the shearing stress and crushing stress. What are these? We'll just see with the problem. So you basically have to remember three things here. Design the shaft first, and then the muff or sleeve, and then you can go with the design of the key. So it is very simple. Let us see the procedure. Design a muff coupling which is used to connect two steel shafts transmitting 40 kilowatts at 350 rpm. So this question states, design a muff coupling. You have to design a muff coupling which is used to connect two steel shafts. So as you all know, we have two steel shafts which need to be connected to transmit power. So that power is 40 kilowatts. So when you transmit 40 kilowatts of power at speed, see here, the speed is given 350 rpm. So the speed is given. The material for the shafts and key is plain carbon steel. So they have given the material. They have given the material for this shaft and the key is plain carbon steel, for which allowable shear and crushing stress may be taken as 40 megapascals and 80 megapascals respectively. So they have given you the stresses that will be induced in the shaft and the key. So these values they have given you. So you need to see to it that when you design the coupling with the shaft and the key, the stresses in that coupling and the shaft and the key of the coupling should not exceed this 40 and 80. The material for the muff is cast iron. So they have given the material for this muff. They have said that the material for the muff is cast iron, for which the allowable shear stress will be assumed as 15 megapascals. So this is the sleeve or the muff. They have said that this is manufactured by cast iron. So the stress in this should not go more than 15 megapascals. So let us use the calculations and see how to design this coupling. Now they have given you the values. Using the values you just have to design it. So first let us write on the given data here. Initially write the same thing which is given in the question. Power is P, 40 kilowatts, or that same thing can be written as 40,000 watts. Next is speed. Speed is N. You can take the notation N. You can use any notation for speed. The textbooks are referring using the notation as N, so I have written it as N. So N is 350 rpm, that is revolutions per minute. Allowable shear stress. You all know what is shear stress. So we have discussed in the class. So this shear stress which is allowable in the material for shaft and key is 40. It means that when the shaft is rotating, whatever is the shear stress in the member should not exceed, it is allowable given is 40. So you cannot have more than 40 Newton per meter square or megapascals, both are same. Crushing stress. So this stress is basically about the key or shaft getting crushed. So the key gets crushed when there is huge amount of stress. So this crushing stress they have limited to 80 megapascals or 80 Newton per millimeter square. So this stress should not cross 80 Newton per millimeter square. Next one is allowable shear stress in cast iron muff. So just here, this is from the question. All this data is from the question itself. Shear stress tau S. You can take any notation here. Here for crushing I have used sigma C. You can use any other notation if you are feasible with that, or you can use any notation here for this also, but just see to it that you properly substitute the values in the equations. So here it is tau S. Allowable shear stress, maximum allowable shear stress in the muff is 15. It should not go more than 15. So now let us design the shaft. So you all know design for shaft in this. Okay, first point is design for shaft. So now, as you can see here, we have given written the given data. So now we'll be writing design for shaft. First we'll design the shafts. Okay, so first one, you need to find the torque. As you all know the equation, this equation is in handbook. As to how to use the handbook, we'll be discussing in the next videos. Right now we'll just understand how to solve the problem. So design of for shaft. So how to design the shaft? You will have given the torque. You will have given the power. So using the power, you need to find the torque. How to find it? P is equal to 2 pi nt by 60 is the equation which you all know already. So you have the P with you. You have the speed n given to you. You just don't know the T. So you can write the equation in this manner also. So take the 60 this side and put all other things down. T is equal to P into 60 by 2 pi n. This equation can be written in this form also. Or else you can just substitute the values and later on you can shift. See here, the same equation I have written once more. P is equal to 2 pi nt by 60 is the equation. You don't need to memorize all these equations. The equations are available in the handbook. So I'll just write the values. P, what is the power? 40,000, which we just saw, which we have just written down. 2 is written as it is. Pi written as it is. N is speed. It is 350. T is written as it is. 60 is written as it is. So now I need T. So I just shift 60 here and take all these three on the bottom. So I get T is equal to 40,000 into 60. This is easily understandable. 2 pi into 350. I have written it as it is. So after you solve this in the calculator, you will be getting a value 1100 Newton millimeters. This is in Newton meters. 1100 Newton meters. So this Newton meters, I'll just write it in millimeters. T is equal to 11,000,000 Newton millimeters. So when I convert this meter to millimeters, I get 3 zeros here. So what I obtain now? I obtained the torque. Torque is what? The twisting force. When the shaft is rotating, there is some twisting force acting on that. This twisting force is nothing but this torque. So I obtained the torque value now. So once I have obtained the torque value, based on this value, I'll be able to find the diameter. So you all know this equation. We have this equation in the handbook. Diameter D. As to where are these equations in the handbook, we'll just discuss in the further videos, which I will make separately for referring the handbooks. First, let us understand solving the problem. So the equation for torque is torque transmitted by a shaft. That is T is equal to pi by 16 Fs d cube. This is the formula for power transmission through a solid shaft. You all know this equation. You have used it in strength of materials. So I just put this torque value here. Pi by 16 written as it is. Fs is, see here now, this is a very important point. Fs or tau s, you can use any notation here. Fs is nothing but the same thing. Allowable shear stress for shaft. It is 40. This 40, I take it and I put this 40 here. So we are designing the diameter for the shaft. So we have to put the value for the shaft, that is 40. So write the 40 here. D is the diameter, which I don't know. That is what I'll be finding out. So then keep D here as it is. Take this 16 onto the other side. 16 into this torque. I've written it here. And these two go on the bottom. So 16 into the torque divided by pi into 40. Here I have D cube. This cube goes on this side and it becomes a cube root. So you solve this whole thing in your calculator, you will be getting the diameter as 52. You can take it as a round figure, 55 mm, say 55 mm. So now what did you obtain? Just here you obtained the value of diameter of the shaft. If I want to transmit this much amount of torque, which is obtained by this power, for this power, this is the torque which is available. To transmit this much amount of torque, I need the diameter of the shaft to be 55 mm. So now you understood the diameter of the shaft. So this is the first part which we understood now. So what we have found out now, and if you see in the procedure, design for shaft. First we found out the torque. Then we found the diameter. So we have got the value of diameter for the shaft now. This is over. So let us see the design for sleeve or muff. The next one is design for sleeve or muff. So first we need to find the outer diameter of the muff. There is a formula given in your handbook which we'll see later on. First let us see the formula. What is the formula here? The diameter, outer diameter of the muff is given by capital D is equal to 2D plus 13 mm. As to how these are obtained, we will discuss in the classes. Right now we will just see solving the problem. 2 is written as it is. D is small diameter, that is the diameter. Small d is the diameter of the shaft, which we have already obtained here, 55. The same thing I'll write here, 55. As I told you, we will design the muff based on the shaft. We will design the muff based on the shaft. So now I need to use the diameter which I have designed here. Take the 55 here, 2 into 55 plus 13 mm. So I'll be getting a value 123 mm. You can round it off and say 125 mm, that is a round figure. You can take the higher value, 125 mm. So then the next one is length of the muff. The formula for length of the muff, to find the length of the muff, this is the length of the muff. Now we found out the diameter. We found out the diameter of the muff. Now we'll find out the length of the muff. So length of the muff is L is equal to 3.5D. That is, D is this 55. I just put it here. I get the value 192.5 mm, and that you can just try and round it off. 195 mm. You can take the higher value, and then now a very important point. Check for induced shear stress in muff. Okay. This is a muff. Now what you need to do here is, you all know that the muff is rotating along with the shaft. So if you can see, when I have the shaft and the key inside, this is the way it is fitted. So when this starts rotating like this, when it starts rotating in this way, there is shear stress. You know what is shearing stress already, we have discussed in the class. So when there is rotational motion, there is shear stress induced in this part of the muff. So we need to check whether the shear stress induced in the muff for the values which we have designed is more than 15 or less than 15. If it is more than 15, if the value of shear stress is more than 15 in this, then we need to change. If the value is less than 15, then it is not a problem because it is safer. So let us see that. Check for induced shear stress in muff. See, they have given you already that the stress should not cross 15. Allowable stress is 15, which you already seen. We have seen here. The stress for the muff, shear stress, is 15. So the value should not cross 15. So we'll just see whether it will cross 15 or no. Check for induced shear stress in muff. Muff considered as hollow shaft. So if you see this muff, it is basically a hollow shaft. So we will consider the muff as a hollow shaft, and then you all know from your strength of material subject, the equation for a hollow shaft is T is equal to pi by 16 Fs. D, capital D raised to 4. Capital D is the one which you designed. Capital D is the diameter of the muff, and small d is the diameter of the shaft, that is the inner diameter or the shaft diameter. Both are same. So D is outer diameter, small d is inner diameter, divided by the capital D, that is the outer diameter. So this is d raised to 4 minus small d raised to 4 divided by d. So we'll just put the values here. T is torque, which you all know. So basically we'll be designing for the same torque. So write the same value here. T value, just write it down. Pi by 16 Fs. We want to see what will be the value of Fs here. What is Fs? That is the shear stress. You can use the equation tau s Fs or any other notation which you feel you can remember easily. You can use that equation. I have written Fs here. You can use Fs, tau s, anything. So D, capital D, which we just designed here, as you saw, it is 125 mm. So the same thing I have put here, 125 mm minus 55 raised to 4, 125 raised to 4 minus 55 raised to 4 divided by 125. I've just put the values here, and then we need to find out Fs or tau s, anything. I want to find this, so keep this here, transfer all other things to the other side. 125 and 16 go on the top here, this into 16 goes here, 125 goes here, and the remaining things, pi and these two things, come at the bottom. You can see here, torque, 16 is put on the top, 125 is put on the top, the remaining part, that is pi, 125 raised to 4 minus 55 raised to 4, the whole thing is put here. So just calculate this in the calculator, you will get 2.97 Newton per millimeter square. So what does this mean? The stress which is induced in the muff, the shear stress which is induced in this muff when this shaft is rotating, the value is 2.97, which is way less than 15. So you can find that design of muff is safe. So yeah, I think you have understood this. We have designed the shaft. Based on this shaft we designed the muff. So for this muff and this shaft, what is the shear stress induced? We got the value as 2.97, which is way less than 15. It is less than 15. So the design of muff is safe. So the shafts which we have designed, the diameter of the shaft is safe. Next thing is, now what would we do? We just have done this. We have done this part. I hope you have understood what is checking of shear stress. Okay, so first we did this, then we did this part, design of sleeve or muff. We found diameter, we found out the length, and then we checked for the shear stress. So last part is a simple thing. We'll just see for the key. Design for key. Let us see the design for key. So here, refer table. There is a table in your handbook. We will discuss about all those things later. Just there is a table. In that table we will have values of width and thickness for the key given. So this is the key. This is the key. For this key there will be a standard width and thickness. There is a standard width and thickness available, which is in the handbook. So for this diameter in the handbook, I'll show you how to see the handbook later on. So first let us understand solving the problem. For this diameter of shaft 55, width is 18. So the width of the key will be 18 mm. Here in this problem, the crushing stress of the material is twice the crushing stress of the material. As you can see here, I'll just show you. If you can see here, the crushing stress is 80, whereas allowable shear stress is 40, crushing stress is 80. So this is half of this. So when such condition is there, what we will do is, we will take, given crushing stress for key material is twice the shearing stress, therefore use square key. We will be using square key. We will be using a square key. So here we are using a square key. As to why are these considerations done, we will discuss in the class. So here crushing stress is twice of shearing stress, so we are using a square key. It means that when the width is 18, the thickness also will be 18. So I have a square key.